Let's move on to an example about mechanical energy. Here we have example 1 about wind energy. Okay, so that is a site evaluated for wind farm. Okay, that is observed to have steady winds at a speed of 8.5 meter per second. Okay, although it has a figure originally in this question, but actually the figure is not necessary. Okay, you need to determine the wind energy per unit mass, and for mass of 10 kg and for a flow rate of 1154 kg per second for air. If you would like to practice, then pause this video and think about it for some time. Okay, well, I assume that you have done this example by yourself, and let's see the solution. Okay, here we are asked to find out 3 things. The first one would be the energy per unit mass. Okay, so what's the energy? Okay, we need to calculate the wind energy, and here we assume that there should be no any potential energy contained inside this wind energy, because it's not the energy that we would like to extract. What we would like to extract is the KE. So that's part A. The wind energy per unit mass will be small letter e, okay, and that should be equal to small ke. Okay, we only have this term, okay, because that would be the wind energy we would like to extract. So we will have V squared divided by 2. Okay, we just plug in the expression, and then you just plug in the values 8.5 squared divided by 2. Okay, so let me have some calculation. 8.5 squared divided by 2. Okay, as you can see, that will be 36.125. Okay, so we will write it as 36.1. Okay, so correct to 3 significant figures. Got it? Okay. Part B, we need to evaluate the wind energy for mass of 10 kg. Well, that's easy, because we know that the total energy, we just have a KE. Okay? So that it will be equal to mv squared divided by 2. Okay, and we finally plug some values into it. 8.5 squared divided by 2. Okay, well, one reminder, as long as the units you use here is the SI unit, then after calculation, your unit should be also in an SI unit. So here we will also have joule in this case. So we will have 361 joule, correct to 3 significant figures. Okay. Oh, sorry about that. For part A, because it's unit mass, so it should be joule per kg. Okay, it should be joule per kg. Sorry about that. Okay. So part C, we need to find out the wind energy for flow rate of 1154 kg per second. So we have the flow rate, then the wind energy you calculate should be in the rate form. So that should be the wind power. Okay, in this case, it will be equal to m dot times E. But we know that the E will be V squared over 2. So that after some transformation, then you plug in the value. M dot will be 1154. And then V squared is 8.5. Okay, and then I also calculate this 1154 times 8.5 squared divided by 2. So that will be 4168.25. Okay, so we will have 41700 joule per second. That is what? Correct to 3 significant figures. Okay, or you can also write this term in terms of kilowatts. Okay, to avoid writing so many zeros, so you can also write it to be 41.7 kilowatts. Okay, so that is also acceptable. Okay, depends on your preference. Okay, so that will be example 1.